Okay, so with this next one we have 321 nanoseconds, and we want to figure out how many seconds that is. So we've seen this on the front page with nano, but we have 321 nanoseconds. So I want to get rid of, so I'm multiplying it by some fraction. I put nanoseconds down below because that's what I want to get rid of, and seconds up top. I put 1 next to the bigger number. Nano is 10 to the minus 9, so it's less than 1. And then I would then need 10 to the 9th of these in order to, that's a 9, in order to get rid of these 321. And then the nanoseconds cancel out with the nanoseconds, and I do 321 divided by 10 to the 9th, and I get 3.21 times 10 to the minus 7 seconds. Okay, so that's 3.21 e to the minus 7. Okay, so just a little shorthand, just to actually, well, putting it that way, the e to the minus 2 is just another way of saying times 10 to the minus 2. Okay, so for the following, I threw this into my calculator and it will spit out 190.4. And I want to do two things. One, I want to round it to 2 sig figs because this has 2 sig figs, this has 2 sig figs, so I want to round this to 2 sig figs. So 1, 2, so I want to round it to 190. And then I want to put it in scientific notation. So 1.9, and I'm moving the decimal 2 places. So this is 10 to the 2. It's a 2. Okay. The next one I have is I get 500,000, but I want to write that in scientific notation, so it's 5.0 times 10 to the 5th. This next one, I got to make sure that I square this value, so please be sure to use the e function here, especially if you don't want to include the parentheses. And then you should get 8.9 times 10 to the minus 9. On this next one, I got 2 million, or 2.0 times 10 to the 6th. Now, for all of these numbers all have 2 sig figs. So if you have something slightly different, what I did is I rounded it, all of these, to 2 sig figs. All right, now for this next one, this is a little tricky. I want to get a unit of area in meters squared. So there's a hint. It says convert centimeters to meters before multiplying. Okay, because it's a little more challenging to compute or to convert square centimeters to square meters. So it's just always easier to convert each unit of measurement to the unit that you're trying to get to, then multiply. So I take my 5 centimeters, I set up a conversion just like before, centimeters down below, meters up top, 1 and 100. Centimeters cancel out, and I multiply the 2, I get 0.05. And I'm going to repeat the same process for 10 centimeters, and you should get 0.1 meters. And then if I multiply these two numbers, I get 0.005, so 0.005, and then I want to express this in scientific notation. So I move the decimal 1, 2, 3, and so I get 5 times 10 to the minus 3 square meters. Okay, so if you have something different, be sure to convert your units first. All right, likewise, I want to take my mass of 0.234 kilograms and first convert that into grams. So kilo down below, grams up top, kilos bigger, 1,000 grams in a kilogram. Kilograms cancel out. I get 234 grams. And then 120 centimeters. Do my conversion, centimeters down below, meters up top. Meters are bigger, 100 centimeters in a meter, centimeters cancel out, and so I get 1.20 meters. Now multiply these two numbers, and I get 195, but then written in scientific notation, it's 1.95 times 10 to the second grams per meter. All right, so for this next one, we're doing ratios, and there is a hint that ratio means the two values expressed as a decimal. So what I want to do is I want to do the mass of a proton to that of an electron. So mathematically it looks like this, the mass of a proton to the mass of the electron. Okay, and this first number, 1.67 times 10 to the minus 27 kilograms, and then this next number, which is actually not the exact number. It's 9.11, but anyway, 9.0 times 10 to the minus 31. Now, there's an important thing that I want you to notice here, and this is probably a little bit on the newer side for you. That's what happens when you multiply or divide units. Kilograms over kilograms actually turns out to cancel each other out. It's kind of like x divided by x. So you end up getting a unitless number, okay? And since we actually have a bigger number up top, we should get a value greater than 0, or greater than 1. So we have 190,000. Okay, and I round that to 2 sig figs. I think it's like 1860. And then I want to write this in scientific notation. So I want to write it as 1.9 times 10 to the third, because I'm moving it over 1, 2, 3, and unitless number. So I'm done. All right, on the next page, this is where things get a little bit tricky. We're doing some algebra, but we're not doing x and y's. We're using some physics equations. So what we want to do with all of these is first solve for the variable asked, and then we're going to plug in some numbers. Okay, so I start off with a equals f over m. Maybe it's a little easier to think of it like this as opposed to a little slash. All right, so I want to get m by itself. Okay, but I notice that m is in the denominator. Okay, we can't simply just divide by f. Okay, so what I need to do, there's a couple ways of thinking about it. I could think about it as setting this up as a ratio a over 1 and then cross multiplying f times 1, a times m. Okay, which is what I'm actually going to do. I get ma if I cross multiply that way, and then f times 1 is f, so that's my first step. And then this is the easier step. I divide by a on both sides. My a's cancel out here, and I get my m is equal to f over a. And then if I plug in some numbers, I get 6 divided by 1.5, and that's my m. Now, actually, something that's going to be useful later on, this is kilogram times meters per second squared. This should actually be meters per second squared. So it's 1.5 meters times divided by second squared. And then when you do meters per second squared divided by meters per second squared, those two numbers cancel out, and you're actually just left with the unit of kilogram. And then 6 divided by half, you get 4 kilograms, and that's my answer. Okay. The next one, once again, a couple ways of thinking about it. Okay, if you're consistently getting everything correct, then go with the way that you like to do it. But when I see multiply by half, I can undo that by multiplying both sides by 2. Okay, because you could do anything to an equation as long as you do it on both sides. So by multiplying both sides by 2, that cancels. This is now just 1, so it's gone, and I got the 2k on that side. Then I have this m times v, so undo that by dividing by m. And then I have v squared, so if I square root both sides, I get my final expression that v is equal to the square root of 2 times k divided by m. And then if I go ahead and plug in some numbers, you should get 4 meters per second. Okay, so some more practice on this. We have this first one. We have p equals v squared over r. So let me do that over here. So p is equal to v squared over r. Sometimes, once again, it's a little easier to write it with a fraction as opposed to a slash. So I could think about it cross multiplying, v squared times 1, p times r. So I get p r equals v squared, and then the last step is dividing by p. Okay, so I get r is equal to v squared over p. And then if I plug in some numbers, I get 10 squared, 100 divided by 200. I get a half of this unit. We don't need to worry about the units right now. And then for v, if you rearrange this for v, I have p is equal to v squared over r. Okay, I want to get v, so once again, first step, cross multiply by 1 times v squared, and then r times p, pr. and then square root both sides. So you should get the square root of p times r. And then this is actually, there's a mistake on the key here. This should actually be, when I went through this, and I think I got 2.5. Let me double check that. Yeah, so this should actually be 2.5. Okay. All right, so now solving for a, and this is going to be a little bit more complicated because we actually have a couple steps to worry about. So I have plus 2as. Okay, so the first thing I have to do is actually I'm adding this u squared to this side. So my first step is subtracting u squared. So that gets rid of that. And then on this side, I have subtract u squared. So let me just rewrite it over here. I get v squared minus u squared equals 2as. And then I'm trying to get a. So a is bound, it's multiplied by 2, and it's also being multiplied by s. So if I divide by 2s, I could do that on both sides. And that cancels out the 2 and the s, and all I'm left with is the a over here. Plug in, okay, sorry, jumping ahead. So I get v squared minus u squared all over 2s. That's my expression for a. And then if I plug in some numbers, you should end up seeing that your a is 16. Now, if I'm solving this for u, I'm going to start over here. I got v squared equals u squared plus 2as. So I want to first get rid of this 2as, so I'm going to subtract it from both sides. Okay, subtract 2as. So I get v squared on this side minus 2as. That is equal to u squared. Right, those cancel out. And then I got to square root both sides. So u becomes the square root of v squared minus 2as. Now, when you're plugging in numbers, actually, I want to show you this because there's an important thing. You may actually have this correct, but then you might be getting something different than 5. This is 3 squared minus 2 times minus 2 times 4. Okay, so this minus 2 and subtracting, these two negatives become a positive, and this becomes 3 squared plus, what is this, 2 squared, 4, 4, so it's 3 squared, 9 plus 16, so this actually works out to be radical 25. And that, of course, then is how we get the 5. Okay, so that's all for now. Thank you for listening, and if you have any further questions, please come see me. All right, thanks for listening. Have a good night. Bye-bye.